Okay, so now we're gonna stop kind of talking about the different hazards that we can experience with severe weather, and we're going to talk about the human interaction with weather itself. So overall, we know that human interaction with weather has made the overall global climate a little bit worse. So part of the reason of this are the things listed down here. So some of the things about land use practices may increase the effects of weather events. For example, plowing croplands in a specific way after the full harvest and leaving the topsoil exposed to wind erosion will significantly increase the dust storms, which is exactly what happened in the Dust Bowl in the 1930s, for example. Also, locating mobile homes, in areas of risk to, say, mountain windstorms or areas that have more heat waves or drought is not a very, smart move for us humans in terms of natural hazards natural disasters themselves, actually. Another thing that we tend to do that is not good for the amount of hazards that we experience is land use practices in cities, which can in fact intensify the effects of heat waves. So as I said in the previous slide, this urban heat island effect basically makes cities a lot warmer than the surrounding countryside. How it does that is that by having concrete as being the main kind of structure in the ground, we no longer have the plants that usually tend to cool things off because of the overall photosynthesis process. Instead, the concrete is basically going to absorb all the heat and not re-radiate it back to the space, for example, to the atmosphere. Also, because of the heat island effect, because we are producing more pollutants, those pollutants are going to stay near the city, and they are going to basically create a greenhouse effect that is at a lower level than the global greenhouse effect, but it still happens within cities. So overall, it is rising the temperatures in the cities about 12 degrees Celsius more than the surrounding countryside, which is a huge amount. This urban heat island effect, for example, is super apparent in Latin American countries. As you know, again, I am from near Bogota. So I lived in a smaller town. In fact, I lived outside the town in a kind of rural area. And it used to be easily 5 degrees Celsius, maybe even more, colder in the mornings and even during the day than it was in the city. When I used to stay at my grandparents' place, which lived in the city, I didn't used to have to carry my fleece over. It used to be fine at night, but whenever I was at home, I had to definitely carry a fleece, and perhaps sometimes I would have to even have a hat because it was much, much colder. So it is a very apparent effect, and if you've ever lived in a city and then maybe traveled that same morning to the countryside, you're able to feel that effect very apparently so. So again, our interaction with weather overall, on looking at it on a large scale, is affecting by global warming. So although global warming, it is proved, we don't know exactly how much is contributed by humans. We know some of it is the overall cycle of our Earth, but we do know that we do contribute a certain amount. So if we are able to control our contribution, then we can, make it less apparent or mitigate it, if you would. We also increase heat waves and the intensity of precipitation events. So we've gone through this in the climate change chapter. By our creation with this global climate change, as we're seeing, we're basically increasing the seasonality, and by increasing the seasonality, we're also increasing the incidence of severe weather. So we're increasing the amount of hurricanes, typhoons, and tropical cyclones, as well as droughts, windstorms, intercontinental windstorms, overall processes, which obviously cause a lot of hazards. So we can reduce our impact by increasing the reflectivity of urban surfaces. That way we would basically minimize that urban island effect. We can also increase the amount of pervious pavement in cities. That way we can have air access and moisture to the soils. Within cities, for example, we don't have as much concrete and we have more plant action, if you would. And then we can add vegetation by using, having parks and having rooftops with vegetation, in fact. So if I'm not wrong, Boise is actually a pretty good city in terms of the overall impact that we are creating. We have a lot of parks, which is great. But we can also contribute a little bit further by perhaps in the higher buildings adding rooftops that have vegetation within them. Other cities are obviously more of a risk in that scenario. Some of the linkages that these severe weather hazards have with other hazards are as follows. So on the long term, we know that climate change is the overall kind of link, or the big one. But they're also linked to obviously large tropical and extratropical cyclones, which we will look at next week. They're linked with the stagnation of a front, for example, a warm front near mountainous terrains. So this front of thunderstorms or even windstorms near mountainous terrains causes these flash floods, which is the case for the flash flood in 2013 in Boulder, Colorado that we saw on chapter 6, for example. They're also linked to subsidence, which again I described a little bit a few slides ago when I talked about the heat wave in Europe, how the melting of the permafrost basically caused the volume to reduce, the overall soil to be unstable, and caused the mass wasting events that followed the subsidence event as well. More directly able to link the severe weather processes are, however, smaller amounts of flooding, due to thunderstorms, basically. Mass wasting events, such as, with windstorms, you tend to accumulate certain things in places, and also wildfires. So with the wildfires, for example, lightning is the main driver of them that ignites a wildfire itself, or ignites the wood. And so lightning actually, or 1 in 4 lightnings has the capacity to ignite. So it's not very many. So every 4 lightnings that actually reaches the ground, only 1 of them is able to ignite. So it's not that many, but depending on the amount of wind and the amount of moisture or of where the lightning might ignite, you're gonna get a bigger wildfire or not. So we'll go over wildfires in a lot more depth in a couple weeks on chapter 13, so I'm not going to go too much in depth with that. But those are the different linkages that you can see with other hazards, and I encourage you to look at some more. Obviously, severe weather has many different processes and hazards, so I'm sure that there are more ways in which we can think about these. On the positive side, some of the natural service functions of severe weather itself are the following. So the same kind of reason about it being bad, if you would, to wildfires is also a good thing. As you know, wildfires are vital for certain prairie, tundra, and forest ecosystems, so they need to happen on a somewhat regular basis. The problem comes when you have too much of it, but this is not necessarily due to lightning, but perhaps because of the moisture and the bad regulation that we have on this. Another thing that can be good are windstorms. Certain times windstorms, when they happen in forested areas, they topple dead and deceased trees, which will overall recycle the soils in the forest. Along with that, you can get clearings, for example, where those deceased or dead trees used to be, and those clearings can be used by new plant growth, or even animal species can use them for whatever they need to. In terms of the hydrologic cycles, sometimes these thunderstorms or blizzards or ice storms or whatever it may be are the only sources of water to certain areas that don't get like regular water from precipitation. So sometimes these massive severe weather hazards are the only instances in which water can reach those times. So it's also important for the hydrologic cycle in certain areas. And lastly, it can also be, beautiful to look at some of these massive hazards, such as tornadoes. And in some cases, it's even touristic. So actually, in the tornado alley, so again, those kind of Great Plains kind of states in the middle part of the U.S. in the Great Plains, there are certain tourism kind of companies that offer tornado chasing tours, which is also very dangerous, but I'm sure would be very, very cool. I'm pretty sure that the picture from the beginning of this PowerPoint was taken from one of those tornado chasing tours. And that's what you're seeing here on the bottom. What you're seeing, the picture on the top, is actually from a forest fire that I think happened in the 90s in Yellowstone, and now you're seeing that obviously the vegetation is growing beautifully after that. In order to minimize the severe weather hazards, the idea would be to be able to predict these events in order to reduce the hazards. However, the behavior of these severe weather events is pretty much unpredictable, and forecasting is fairly difficult. One of the key things that we use nowadays is the Doppler radar station. So you may have heard of them or seen them before. This is one of them, as you're seeing in the image right there. They have their name also because of the Doppler effect, as you may have heard of it before. Usually we hear of the Doppler effect based on sound. So if you hear like an ambulance, it sounds differently as it's coming closer to you as it's going away from you, basically, but it's the same idea. So these Doppler radar stations have improved our ability to predict the path of a storm. So how they work is that they send out an electromagnetic radiation that has a wavelength a bit longer than that of microwaves. As raindrops and clouds and ice particles are there, as well as other objects like dust, they will reflect back these waves, as also electromagnetic waves that then reflect back to the receiving antenna. The wavelength that is received in the signal changes if the storm is coming closer to you or going away. So over a course of time, if you see that the wavelength is getting smaller, then that means that the storm is getting closer to you. But if it's getting longer, then that means that the storm is going away from you. So this can allow for warnings of these massive storms for, 30-minute warning, which may be enough for families to, gather their things and go to a safe space, for example, or a safe room. So that would be good. Another thing that improves or minimizes the severe weather hazard are watches and tornado warnings. Not necessarily tornado, but any type of warnings. For tornado watch and warnings, usually they are done 4 to 6 hours in advance, and they usually give you an hour, or sorry, not an hour, space between 52,000 and 104,000 kilometers squared where the tornado might happen. For a watch, it's only an alert, so it's not a warning per se. The alert says that basically this might occur or it might not. But once a tornado is actually sighted, this alert becomes a warning. When you are given a warning, then people should actually take immediate action and protect themselves and others in shelters and whatnot. So these watches and warnings are implemented for also heat waves, for thunderstorms, for blizzards, and for windstorms. So they're fantastic. However, many a times people may grow weary if events don't come after warnings are issued constantly, and they may not be prepared for future warnings if, many a time it's like cry wolf, right? So if I say there's going to be a tornado happening and it doesn't happen, and I keep saying it and it doesn't happen, and then I said it again, people may not be prepared because they're used to it not happening. So obviously that discourages people. Okay, lastly, I have this slide. I'm not going to go through it because I'm running out of time on this video. But basically, I didn't really have anything else to say apart from what is written. So I encourage you to read this slide. Make sure you understand the mitigation strategies and the preparedness and personal adjustment strategies in order to minimize severe weather hazards. All right, guys. I will talk to you next week. Have a wonderful week. Email me if you have any questions on anything, discussion boards, labs, anything.